learn iterative statements in C. In C, there are two main types of loops, the entry control loop and the exit control loop. Under entry control, we have the for loop and the while loop. The syntax of the for loop is as shown here, for, and then within parentheses, there are three components separated by a semicolon. The initialization of the control variable, the condition for how long the loop has to happen, and the updation of the control variable. And this updation obviously can be either incrementing or decrementing the control variable depending upon the initial value. And following the that line, we have the loop body enclosed in curly brackets. If the loop body has only one statement, then the curly bracket is not needed. When several statements are to be done as part of the loop, then obviously we need a block which is represented by the curly brackets. If you do not have the block mentioned, then the first statement following the for alone will be considered as a loop body and done repeatedly. The rest of the statements will be treated as a common statement which will be done once after the loop is over. Now, to show why the for is an entry control loop, an example has been shown here. I basically want the word hello to be printed 5 times. So, I have written a loop like this. The order in which the for loop is done is, the initialization part is the first step that will happen. In the second step, the control variable's condition is checked. If and only if the condition is true, as a third step, the loop body is done. And then that will be followed by the updation of the control variable, and thereafter, after updation, the condition is checked, the body is performed, the updation is done, and that happens in a cyclic way. But here if you notice, x is initialized to a 5 and 5 less than equals 1 is not true. Therefore, straight away the loop body is not executed even once. So the correction must have been, because the updation is properly done as decrementation. So for x to take values 5, 4, 3, 2, 1, this must have been a greater than equal to. So because the condition was not true in the very first check, the loop body is not even performed. So this is called entry control, checking of the control variable before entering the loop body. Therefore the for is a entry control. The syntax of the while goes like this: initialization of the control variable followed by while, and in parenthesis the condition for looping. Following that we need a loop body, and here the parenthesis, the curly bracket is very much necessary, because even though the loop body is only one statement, the updation of the control variable also is going to be part of the loop body. So here the curly bracket is definitely mandatory. And again, to show the same example to show shown here as to why while is a entry control. So x has been initialized with a 5, and then as long as x is lesser than equal to 1. So like before, 5 less than equals 1 is not true. Therefore the rest of the loop body is not done at all. So for and the while comes under entry control loop, whereas a do while comes under exit control loop. The syntax is like this: initialization of the control variable followed by the word do, and then the block, within the block the loop body. So the loop body is performed at least once, and the check is done only after the loop body is performed once at least. So even if the condition was false here, the loop body would have happened at least once. So the condition being checked on exiting the loop, therefore the do while is called the exit control loop. And the same example has been shown here. So print hello would have been printed at least once, after which only the condition would have realized the 5 decremented by 1, that's a 4 less than equals 1 is not true. So let's look at more examples to understand these loops better. So to look at examples, first we'll have the for loop covered. Let's try and display the first, say, 10 even numbers in descending order. Now with the for loop, so we'll have the control variable x declared, and like I said, for the 10th even number will be 2 times 10, that's a 20, semicolon, and as long as x is greater than or equal to 0, and x has to be updated as minus equals a 2, because we want even numbers shown. And then within the body we shall have the value of x shown, the format specifier, and we'll want the values probably separated by a tab space. and each time I want to show the value of x. So let's execute this and see. So the first 10 even numbers 2, 4, 6, 8, 10. Okay. Definitely we do not want a 0 included. So you can have the condition until greater than a 0. Now this will be a very simple for loop to display the first 10 even numbers in descending order. Now there are certain variations in the for. Variation number 1, I can have my control variable declared as well as initialized. So I'm giving the initialization along with my declaration, in which case I can skip the first component of the for, that is the initialization part. So when I run the code, I'll get the same output. The second variation will be the updation that's happening in the for. I'll try and do it within my loop. That is, every time after my x value is displayed, I'll have the updation of the control variable done within the loop, because now it is involving more than one statement. After the print, the updation of the control variable also has to happen. Because it is involving more than one statement in the loop body, we obviously must have had a block. If we don't put the block, only the first statement following the for will happen over and over again. This will become a common statement that is to be done once after the loop is over. But we want the updation to happen within the loop, so we've included the block. And since the updation is happening here, I can omit that component from the for loop. So that is a second variation. So when I run the code, I'll still get the same output. The third component is to omit the condition also. So you could have a for loop which just looks like for semicolon semicolon. But obviously this will be an infinite loop, because this is going to keep happening over and over again. So this way, to avoid a infinite loop, every time after my control variable is updated, I have to check if my x has reached if x has reached 0, then I shall break the loop. So that way I will avoid this kind of a loop to be a infinite loop. And when I run the code, okay, the condition has not been put in parenthesis, my bad. So the condition has, as per the syntax, condition of the if has to come in parenthesis, and when you execute the code, you will still get the same output. This is to show one another variation of the for, where the control variable can be declared within the for. It need not be declared once outside and then used inside. So inside the for loop syntax itself, the control variable can be declared as well as initialized. So this is to show the first 10 natural numbers in ascending order. So when I execute the code, the output has come like this. And so in this example, we are going to see one another form of the for loop, that's a empty for loop. I have a variable declared and the for loop is written like this. I have a terminator at the end of the for loop. So that is going to be treated as my loop body. So throughout the loop where x takes values 1 till 10, the loop is performing nothing. So this is a empty loop, and the statement that is following the loop is going to be treated as a common statement, which is going to be done once when the loop is over. When is the loop going to get over? X is incremented every time. So at one point when x becomes 11, 11 less than equals 10 is not true. That is when the condition becomes false and the loop control comes out of the loop. So coming out of the loop, the x's value will be shown as 11 once. So that is the output that is seen. So such a format where you terminate the for loop, now that is going to be treated as a empty loop, and this will not be considered as part of the loop body. To see one another example based on the empty loop that we just saw, this code is to find the sum of first n natural numbers. I've had the required variables declared. I'm asking for the limit, what my n value is, and now my for loop is going to have, in the first component, that is the initialization, my control variable is initialized to a 1 because it's natural numbers. We need to start with a 1, and my accumulator is going to be initialized to a 0. So this is multiple initializations that are happening in the first component, so they have to be separated by a comma. The second component, the condition is as long as x is less than equal to limit. And in the third component, which is the updation, I can have my accumulator to be accumulated with the value that x takes, and x has to take the subsequent value. Now it's so important the order is maintained. If I had put a x updation of x here before my sum is initialized, sum is accumulated, then the first value of x is going to be skipped. So it's important when you're having multiple updations done here, you have that current x value added to sum, and then you go for the next x value. So multiple initializations, multiple updations. In such cases, we need to put a comma. And since the accumulation is happening within the third component itself, the loop body need not have extra statements, so it can be terminated to have a indicator empty loop. So coming out of the entire loop, I can show the sum of the numbers up till the limit entered as sum. So if you execute the code, if I give the limit to be 10, so for sum of first 10 natural numbers is a 55. Example using the while loop, we'll try and compute the factorial of n whose value is read at runtime. So scanf %t ampersand n. I'll have the accumulator, let's say prod, declared and initialized to a 1. Now the control variable n, I need to traverse, for finding n factorial, I need to traverse all values 1 up till n. So let's have another variable, say x, which takes initially a 1. So x is initialized with a 1, and the loop condition will be as long as x is lesser than or equal to n. So for each value of x, I'm going to have the accumulation happening as prod star equals x, and I need to update x to take the subsequent values. So once this loop is over, coming out of the loop, I can display the factorial of the given number n is equal to, and the format specifier for the result. So for the first format specifier, it should be n's value, and the second format specifier, the value should be the variable prod. So let's execute and see. I haven't given a prompt here above this, so actually the program is waiting for an input here. So factorial of 5 is equal to 120. So if you had wanted a prompt, then probably just before the read operation, you could give a prompt, enter a value. So this is one simple example for understanding the while loop. Now to see one example for the do while. Mostly the do while is best suited for menu driven codes, because even if in the first attempt itself we want to exit the menu has to be shown at least once. So for displaying the menu once, irrespective of whether the user wants to quit, choose exit in the first shot or not, a do while loop is best suited. So this is a menu operation done on a square. I have menu options shown. I'm reading the choice, and if the choice happens to be a 1, I shall read the value of square, side of the square. I have a variable declared to store the side of the square, and with that I shall print option 1 is area. So area of the square is going to be shown as a side times side. Now with that, the first option is over. Else if the choice entered by the user is a 2, then I shall have the side red, using which I'll have the perimeter shown, whose value will be 4 times side. Now we could have had a common reading of the side out here, but if the user enters opts to choose a exit, unnecessarily the side of the square is going to be red. So we are not reading the side of the square outside the checks, we are reading the side within the check of the choices. And probably we can give a prompt here, enter side of the square. Now the final, after both the choices have been statements have been included for the choices, as a final statement we must have had the while loops closing condition. So it will be like, as long as the choice is not equal to a 3, and then the semicolon. So even if the user gets to choose exit, once at least a menu body is done, the choice is read only after displaying the menu, and then the condition is checked to see that it's a 3 and the loop will stop. So let's run the code. So the first choice, when I enter, the side is asked. I must have had a formatting done, so let's choose a 3, and just before having the choice read, I must have had a slash and included just to format. So this is what I said. When I run the code, the menu is shown, and when I choose a choice 3, the code exits. But before exiting, at least once the loop body has been done. So in such a case, the do while is best suited. Coming up in the next video, we'll look at numerical arrays in C. Subscribe for more videos on C programming.